Hey, hello everybody, this is program 123 again, and we are going to analyze the second problem of the contest US Open Bronze of year 2020. We're given n pair of integers which are going to be formed by a number x, which is going to be between 0 and 10 at 6, and a boolean which is 1 or 0 that are going to represent the final arrangement of these pairs. We don't know how exactly they were arranged at the beginning, but we do know that any pair containing a number 1 as its Boolean value passes this value to any other pair whose x is not more than r units away. But you do not remember r either. With this information, we have to compute the minimum number of pairs that should have started with 1 as their Boolean value. I know it might sound confusing for you. Yeah, well, you can analyze this problem a little bit because it's easier than what you think, and you can stop for a little bit and analyze this problem and come back, or you can see the original statement. I didn't include the original statement because it has some words that I better not pronounce here on YouTube. Okay, well, let's try to solve this problem. As an example, we have these pairs, which is 7 1, 1 1, 15 1, 3 1, 10 0, and 6 1. So we have already put our Boolean values in these positions. Okay, so position 1, as you see, has a number 1. Position 3 as well has number 1. Only position 10 has a 0. Okay, so in the problem are asking us for the minimum possible number of pairs that have a 0 as that have number 1 as their Boolean value if they always pass this value. Okay, so in other words, they are asking us to make this r as big as possible. So let's see what is the constraint for this variable r. Well, as we can see, this pair of 15 1 is not going to affect this pair of 10 0 if r is equal to 4, but if r is equal to 5, it affects it. Okay, so for r equal 4 or less than 4, there's no problem. But what happens with the 7? 7 can affect the pair 10 of 0 with an r of 4. You see, 1, 2, 3. We have a distance of 3, which is less than 4, and we said it was okay. So 7 is lowering the value of r that we have to obtain. So this pair of 7 1 tells us that r can be as big as 2 or less than 2. Okay, there is no other constraint except for this one, that is 10 0. I mean, this pair should have been 10 and 0 if r is more than 3. So since r cannot be greater or equal to 3, well, the original arrangement was this. So you see, the first element can have a value of 1 and can pass this value to the position 3 to get this arrangement. There's no problem because r equal 2, at most 2. Now 7 can have this value of 1 originally, and 6 is 1 unit away of 7, so it can pass this value with no problem, and we're good. We have these two number 1s together. Now for the position 15, we have to set the value of 1 at the beginning because there's no other position that can pass this value to the position 15. And as I told you before, this problem is easier than what it looks like. So let's see the code for the solution of this problem. As I have already told you in last videos, I add these lines to try my code without reading from a file, reading from standard input and printing to standard output. Okay, we define the files where we have to read and write from. Well, we are going to declare an array of a pair of integer and boolean. We're going to read this data, and if n equals 1, because the problem says that n can be at least 1, well, let's take this as a special case to make our solution easier to understand. So you see, if the only pair that was mentioned has a boolean value of 1, has its boolean value set to 1, then we should have had this value already at the beginning. But if it is not, well, it shouldn't be set, so we have a minimum of 0. Now let's start this array, and now we are going to check from second to the second to last pair. We check if this pair has a 0 as its boolean value, then we are going to minimize this r that we have already set to see if the distance between the next pair, between the position of the next pair and the position of last pair, is less than what we have already set. That way we are going to compute the greatest r that we can get. And let's take the first and last position as special cases, and we are sure that we can make this because we have already taken n equal 1 as a special case. So we are sure that we are going to have more than one element, so we can do this freely. Now that we have already computed the value of r, we're just going to count the number of pairs that you have a 1 as their original element and not as a past element. So I say if this pair has a 0, then it doesn't matter. It cannot pass a number 1, so I don't care about it. I am not counting it. But if it doesn't, then I gotta see how far can I pass this value of 1. In this case, for example, if I am into position 1, the first pair, then I am going to see that I can pass this value to the third position, and I cannot pass it anymore. So I am counting only 1, and after we have increased the value of I, so you see I am increasing value of I twice, we count this as only one pair that you have the value of 1 at the beginning. And we ask for the last one. In case we didn't pass the value of 1 to the last pair of the input, then we gotta ask if we have to count this or not. For example, if this pair was 15 and 0, then I shouldn't count it. But since it is a value of 1, then I should count it. And then we just print the result, and that's it. We have already commented these lines, so let's run our calc with the example test data provided by USACO, which is this one, and the answer for this problem was 3. As we saw here, 1, 2, and 3 pairs that you have the value of 1 at the beginning, and that's the code. We just have to uncomment these lines. We just have to uncomment these lines to submit it to USACO, and we get this beautiful result. So that's it for today, you guys. Hope you enjoyed this video. Please share with those who need it, and remember to stay home programming, and see you next time with the third problem. Bye bye.